The concepts covered are matchstick patterns, the idea of a variable, more matchstick patterns, more examples of variables, use of variables in common rules, expressions with variables, using expressions practically. What is an equation? Solution of an equation. Algebra is a part of mathematics in which the letter and symbols are used to represent numbers in equations. It helps us to study about unknown quantities. Matchstick patterns. Number of matchsticks used to make first square equals 4. Number of matchsticks used to make second square equals 7. Number of matchsticks used to make third square equals 10. So, the pattern that we observe here is 3n plus 1. With this pattern, we can easily find the number of matchsticks required in any number of squares. Example. How many matchsticks will be used in the 50th figure? Solution. 3n plus 1. 3 times 50 plus 1 equals 151 matchsticks. The idea of a variable. Variable refers to the unknown quantities that can change or vary and are represented using the lowercase letter of the English alphabet. One such example of the same is the rule that we used in the matchstick pattern. 3n plus 1. Here the value of n is unknown and it can vary from time to time. More examples of variables. We can use any letter as a variable, but only lowercase English alphabets. Numbers cannot be used for the variable as they have a fixed value. They can also help in solving some other problems. Use of variables and common rules. Geometry. 1. Perimeter of square. The perimeter of a square equals sum of all sides. Equals 4 times side. Equals 4s. Thus, p equals 4s. Here s is variable, so the perimeter changes as the value of side change. 2. Perimeter of rectangle. Perimeter of rectangle equals 2 length plus breadth. Equals 2, L plus B, or 2 plus 2B. Thus, P plus 2 times, L plus B, or 2L plus 2B. Where, L and B are variable and the value of perimeter changes with the change in L and B. Use of variables and common rules. Arithmetic. 1. Commutativity of addition. 5 plus 4 equals 9. 4 plus 5 equals 9. Thus, 5 plus 4 equals 4 plus 5. This is the commutative property of addition of the numbers, in which the result remains the same even if we interchange the numbers. A plus B equals B plus A. Here, A and B are different variables. Example. A equals 16 and B equals 20. According to commutative property, 16 plus 20 equals 20 plus 16. 36 equals 36. 2. Commutativity of multiplication. 8 times 2 equals 16. 2 times 8 equals 16. Thus, 8 times 2 equals 2 times 8. This is the commutative property of multiplication, in which the result remains the same even if we interchange the numbers. A times B equals B times A. Here, A and B are different variables. Example. 18 times 12 equals 216, 12 times 18 equals 216. Thus, 18 times 12 equals 12 times 18. 3. Distributivity of numbers. 6 times 32. It is a complex sum, but there is an easy way to solve it. It is known as the distributivity of multiplication over the addition of numbers. 6 times 30 plus 2 equals 180 plus 12 equals 192. Thus, 6 times 32 equals 192. A times B plus C equals a times B plus a times C. Here, A, B and C are different variables. 4. Associativity of addition. This property states that the result of the numbers added will remain same regardless of their grouping. A plus B plus C equals A plus B plus C. Example. 4 plus 2 plus 7 equals 4 plus 2 plus 7. 6 plus 7 equals 4 plus 9. 13 equals 13. Expressions. Arithmetic expressions may use numbers in all operations like addition, subtraction, multiplication and division. Example. 2 plus 9 minus 3, 4 times 6, minus 8 etc. 4 times 6, 8 equals 24 to 8. Equals 16. Expressions with variable. We can make expressions using variables like an expression containing variable /s cannot be analyzed until its value is given. Example. Find 3x, 12 if x equals 6. Solution. 3 times 6, minus 12. Equals 18 minus 12. Equals 5. Thus, 3x, 12 equals 5. Practical use of expressions. Example. 3 boys go to the theater. The cost of the ticket and popcorn is Rs 33 and Rs 15 respectively. What is the cost per person? Solution. Let's say x equals cost of ticket per person. Y equals cost of popcorn per person. Total cost of the movie, ticket plus popcorn, per person equals x plus y. Total cost of ticket plus popcorn for 3 boys equals 3x plus y. Equals 3, 33 plus 15. Equals 3, 48. Equals 144. Equation. If we use the equal sign between two expressions, then they form an equation. An equation satisfies only for a particular value of the variable. The equal sign says that the LHS is equal to the RHS in the value of a variable, which makes them equal is the only solution of that equation. Example. 3 plus 2x equals 13. If there is the greater than or less than sign instead of the equal sign, then that statement is not an equation. Some examples which are not an equation. 23 plus 6x greater than 8. 6f, 3 less than 24. The solution of an equation. The value of the variable which satisfies the equation is the solution to that equation. To check whether the particular value is the solution or not, we have to check that the LHS must be equal to the RHS with that value of the variable. Trial and error method. To find the solution of the equation, we use the trial and error method. Example. Find the value of x in the equation 25 minus x equals 15. Solution. Here we have to check for some values which we feel can be the solution by putting the value of the variable x and check for LHS equals RHS. Let's take x equals 5. 25 minus 5 equals 15. 20 is not equal to 15. So x equals 5 is not the solution of that equation. Let's take x equals 10. 25 minus 10 equals 15. 15 equals 15. LHS equals RHS. Hence, x equals 10 is the solution of that equation.